Hello everyone, we will solve today's LeetCode problem. This is LeetCode medium problem. This is subarray product less than k. This is so here is given an array of integer nums and integer k, and we need to return the number of contiguous subarrays whose product of all elements in the subarray is strictly less than the given number k, right? So here is given 10, 5, 2, 6 and the number is 100. So we need to find the subarrays, the number of that subarrays whose product of elements is less than k, right? So the first is 10, 5, 2 and 6. This one subarrays has product less than 100, right? Then again 10, 5 is 50, then it is again less than 100. This is 5 and 2, this is again less than 100. This is 2 and 6, this is again less than 100. Again 5 to 6 is less than 100, but if we multiply all 10, 5, 2, it becomes 100, which is not less than k, it is equals to k. So this will cannot be an answer, and if we multiply all the elements of that nums array, that will also be not an answer. So for this, whenever you see this number of contiguous subarrays, you can think of approach of sliding windows, right? Like you must have solved the problem of subarray of the sum equals to k, less than k or greater than k, right? Subarray sum, right? It is similar to just like that. So if you take an example of this is 10, 5, 2, 6 is given here. You need to find the number of subarrays. Then what will we do? We will just multiply, start multiplying these numbers. Suppose this is 10, then now it becomes 50, which is still less than k, that is 100. K is given 100. So now when we will multiply 2 with it, it becomes 100, right? Which is equals to this k. So now we will this window size, now we will decrement this window size so that this multiplication is less than k, right? So what we will do, we will take another pointer, and we will decrement this jth value from starting 0, and we will divide this multiplication by nums 0, then nums 1, till we will get p less than k, this product less than k value, right? And whenever we get p less than k, we will store that, we will count that answer in my answer variable, right? So what we will be stored, we will store this I minus j plus 1. Why? Because if you see this 10, 5, 2, suppose you see 10, 5, then this 10, this 5 and this both 10, 5, this 3 will be the answer. So if you only do answer plus plus, that will increment, that will take only this one, but don't take this whole values, right? So we need to mark all the range between this I and jth value, right? I hope you have understood. If you there's also many problems like this: subarray sum of equals to k and or less than k or greater than k. You must have solved these problems. So these are some basic problems which you can, these methods are same for all this. These are sliding window approach, right? This is sliding window approach, all the are sliding window approach, right? So let's code it. This is nums dot size. This we need to take a product to store multiplication along the iteration. Here it is given 3 into 10 to the power 4 and nums I can only 1000, so it can only goes to 3 into 10 to the power 7 max, so which can be contained in an int value. So I will also take an answer variable to store my answer number of subarrays, and I also need to take an pointer to, so that I can with its help I can decrease the size of the window, right? So I will start iterating in my arrays, and now I'm start multiplying my num size, right? So I will check that whether this p value is not equals to, if it is greater than equals to k, then we need to decrease our element size. For that I need to decrease my starting jth value, and also I need to increase my jth value till I don't get p less than k value, right. And also need to check the condition that this jth value should not be greater than I. So this is while loop what we do. And after that I will check whether this p is, if p is less than k, then I will simply include this in my answer. Why I'm doing I minus j plus 1? That's the reason. This, suppose this is 10 5 2, this is 100. So suppose this is 10, I have included. Now I will this I minus j plus 1, which is equals to 1, this 10 included. When you multiply 5 again, now if you do I plus plus, then this only 5 will include, but this 10 5 will get left, so we will miss that answer. So for that I need to include this whole range. Then you will include this I minus j plus 1, which is equals to 2. So this is 1 with the previous and 2 now, because this 1 and this 10 5 again, this is 2 value. If suppose this is the only this is also an answer, then you need to take 3 values, because this 2, this 5 2 and this 10 5 2, all 3 can be the answer, right. So that's why you need to take an answer, and ultimately you will just return an answer, right. So yeah, here is the code, right. Just you need to run this. Let's see what happens. Run, let's submit it. Yeah, bingo. So what will the time complexity of this? This time complexity will be O of n, because we need only one iteration, right. And what will be the time space complexity? That will be also O of 1, because we haven't taken any extra space, right. So thanks. uh, Hope you will you also solve this problem. Suppose this is given suppose this is not given less than k, it is given equals to k. Then you will just check this condition that p should be equals to k, right. Otherwise you just need to see p less than k, right. If you see p is equals to k, then you just don't need to take I minus j plus 1, you just equals to this plus plus, right. Because this for less than k, they all the subarrays, the previous subarrays can be the answer, but for equals to k, only one subarray can be the answer. So that's the change you need to take for equals to condition. Otherwise this I minus j plus 1, right. And for greater than k, you just calculate less than k, less than equals to k, and subtract it with the total number of subarrays exist minus that less than equals to k. Understood? So that's the overall structure for this problem. That's the same for this, and this is the same approach. Thanks. Bye bye.